Eric Burgess here, and we've been asked to evaluate the integral of the natural log of the square root of x dx. So looking at this, because we have a natural log, you should immediately think integration by parts, right? If this was just the natural log of x dx, the way we would do this is we would let u equal the natural log of x and dv equal dx. And then from there, you can get the integral. So it's integration by parts. That's our first clue. Now there's two ways to do this. One sort of a just follow the steps way after you've seen that critical insight of using integration by parts. The other way is use some log rules to make your life a little easier. Now me looking at this at first, I'm kind of prone to just start chugging away instead of maybe looking more carefully. So the first thing I would do, let me show you that way first, is I would say, well, let's let u equal the natural log of the square root of x. Say, what the heck, if it works with just regular x, let's just stick everything over on the u side and let dv equal dx. If we do this and we take the derivative of this up here, well, remember it's going to be 1 under the square root of x, and then we have to use the chain rule. The derivative of the square root of x is going to be 1/2, right? Because we pop it off. So this is x to the 1/2. So we pop that off, and then we subtract 1. So it'd become x to the negative 1/2, or 1 under the square root of x. Which this is eventually going to just equal, if we simplify this, 1 over 2x. So that's how you take that derivative. And then this is incredibly easy. This is just going to be v equals x. And there's a dx here that popped out when we took this derivative. So now, doing this, we can simply do our multiply down and across thing. So we would get that above integral is in fact equal to the natural log of the square root of x minus the integral times x. Geez, got to remember to do everything, right? This times this minus this times this, which is actually this down here, the simple version. So this is going to be 1/2, and then x, and then v is x. So that's going to go on top. We'll just write it here. And we've got a dx right here. That sounded more confusing than it needed to be. All I did was multiply this times this. Okay? That's all that happened. That sounded a little confusing there. So just to make it really clear. Okay, so from here we can actually simplify this, right? So this is equal to the natural log of the square root of x times x minus the x is simplified. We're left with 1/2. So we've got the integral. We could pop that out to the front, dx. So this is just going to equal x, and this is equal to, in the end of the day, natural log of x, the square root of x times x minus 1/2 x. And if you want to be really fancy, you can use the power rule, and this will become 1/2 natural log of x times x minus 1/2 x. And what I just did is, this is really to the 1/2 power, right? This right here. And then because it's a log, we can pop that up to the front. So we're just using some log rules, which if you see that, there's a much easier way to do this. So here's the way I sort of thought of doing it first. I said, hey, let's just plug and chug through, and you get this out as the result. But let's say that you want to be a little more creative, and you notice this log rule at the start. Well, if that's the case, we can turn that integral into this instead. We could say, well, hey, let's do that at the beginning. So we're going to have the natural log of x dx. And we could just pop that 1/2 out to the front. And now we've got the natural log of x dx. This is a standard integral that I happen to have memorized, but if you don't, we can just do integration by parts on this. So we're going to have, what do we need? We need a u, we need a dv, which will let equal dx, and u we equal natural log of x. Du is equal to 1 over x. dv, or just, there's a dx here. v is equal to x. So this is way, way, way easier. So we're going to have 1/2 times, and then we're going to get the natural log of x times x minus the integral of 1 over x times x dx, right? These two. So this is simply going to go to 1, and the integral of 1 dx would just be x. So we're left with 1/2 natural log of x times x minus, these are parentheses. Just out of habit, I like to group things. X. And I forgot something critical. There's a plus c on the ends of these. Plus c. And if you distribute this 1/2 in, you will get the exact same thing that we got right here. So we could even write as expected. We did it 2 separate ways and got the same result, which is always a nice thing. And yeah, so this way is, I think, quite a bit easier if you notice the log trick right at the beginning, but you by no means have to. You just are given sort of a more difficult derivative to do. And if you nail the derivative, then you get the rest pretty much for free. If you have any questions about this, feel free to drop a comment down below, subscribe, and hit that bell icon for future videos. And we'll catch you in the next problem.